Welcome to release question number 86 for the Algebra 1 CST questions. It says a pharmacist mixed some 10% saline solution with some 15% saline solution to obtain 100 milliliters of a 12% saline solution. How much of the 10% saline solution did the pharmacist use in the mixture? So I want to set up a table for one like this where I think about it in this way. So I'm going to have my 10% solution here, my 15% solution here, and then my 12% will be here. And we'll say that we started off with X amount of the 10% solution, Y amount. These are going to be different amounts most likely, and so we'll call it Y. So X and Y, and then what did we have for the 12% solution? We have 100 milliliters. So this is the milliliters, and then over here we're going to have the amount of saline specifically. Since this is a 10% solution of saline, we would have 0.10 as a decimal is 10%. We'd have that times X for the amount of saline in that 10% solution, which is having X milliliters there. And then in the 15% solution, we'd have 0.15 times Y. In the 12% solution, it's going to be 12% of 100, which is just 12. So this is the amount of saline in milliliters that would be in these things. And so notice we had X and Y. If we put those things together, the amount of the 10% and the amount of the 15% solution that we have, we're getting that 12% solution. We're getting that it equals 100 milliliters. So in other words, we can say X plus Y has to equal 100. So if that's the case, we could actually solve for X or solve for Y and get the other variable in terms of that. Let's do that here. Let's say that we're going to get Y in terms of X. We're going to have Y equals then 100 minus X. And since that's the case, we could go back to our table since Y equals 100 minus X, and I'm going to recreate that table. I'm going to make the table once again with the same values, at least in the left-hand column here to start, the 10% solution, the 15% and the 12%, but now I can write everything in terms of just one variable. And so I'd have 12% there. The X I'm going to leave the X as it is, I'm sorry. The Y though I can replace with 100 minus X. We know that the amount of 15% solution we put into the mixture would be 100, the total amount, minus whatever this was. So we'd have to have 100 minus X plus the X to get the 100 that we started with. So that's the milliliters still. Notice it's the same column here, just replaced Y with 100 minus X. And then over here, still the same column, the amount of saline in milliliters that we have is going here. But again, I'm replacing Y with 100 minus X. So this is still 0.10X, but this is going to be 0.15 times the quantity 100 minus X. And then this is still 12. So we're solving we're solving for X here. We know that this plus this would have to equal 12. If I put this and this together, that's not really helping me solve for X at all, because I'm just going to get 100 equals 100. The X minus X will cancel each other out. And so let's put these two things together. I know that this one and this one added together should equal this one right here. So I have, in other words, 0.10X plus 0.15 times 100 minus X is going to equal 12. So let's solve this for X now. We can distribute the 0.15. Now, why don't I do this instead, though? I think this is probably going to be even more helpful. So let's forget about that for a moment, or for the sake of this problem, for the sake of simplicity, a lot easier to multiply everything right now, or multiply both sides times 100. So I'm going to take everything times 100 on both sides here. So if I do that, I have to multiply 100 by this and 100 by this part. This is getting distributed through, so I don't want to multiply this and this stuff by 100. It's just going to be this part and this part. And so if I do that, then I would have, it's just moving the decimal 2 spots right here. 1, 2, right here, 1, 2. That's the whole reason for doing that. I would have 10x plus 15 times 100 minus x equals 1200. So a lot easier to solve that now for x, to deal with non-decimal numbers. I have 10x plus 1500 minus 15x equals 1200. Subtract 1500 from both sides. That leaves you with 10 minus 15x would be negative 5x, and that would equal negative 300. If you divide both parts by negative 5, you get your answer for x at least. So x equals, this divided by this, negative divided by negative makes a positive, and 300 divided by 5, 30 divided by 5 is 6, so 300 divided by 5 is 60. This would be 60 milliliters. Now, is this our final answer? Let's think about it before we say, just stop there and say, oh, yep, it's choice A. Let's see. Let's think about it and see if that's the case. How much of the 10% saline? So, was the 10% saline represented by the x variable or by the y variable? It was represented by the x variable. So, this is a correct final answer. The 40% or the 40 milliliters would be with the 15% solution. So you'd have 40 milliliters of that, you'd have 60 milliliters of this. Now with this one you probably could use some trial and error, but I wanted to show you kind of the way that works every time if you can't see how it's all working out. So number 86 should be choice